Okay, so the part 2 for nuclear and radiochemistry starts. So now we will be studying is radioactivity. Now what is radioactivity? In our periodic table, we have seen that there are some of the radioactive elements. What does it cause to be a radioactive element? The first point which causes any element to be radioactive is the nuclei in atoms should be unstable. The elements in radioactive element in are radioactive when nuclei in atoms are unstable. Okay. Now, what is radioactivity? The phenomena in which nuclei spontaneously emits the nuclear particles and gamma radiations to a different nuclei is called as radioactivity. But what does it emit? Which are the rays or which are the particles it emits? This is the most important part. In early standards, you have heard about alpha rays, beta rays, gamma rays. Alpha is positive, beta is negative, gamma is neutral. So these are the rays which are always been emitted. The radiations emitted are alpha, beta, and gamma. The next point is radioactive decay. Whenever a radioactive element starts to decay, it completely depends on the state of chemical combination, the temperature, or even at the age of the nucleus. Understood? A radioactive element decays at the age of its nucleus. If the age or the nucleus starts to decay, there is the radioactive decay. Okay, it also depends on the chemical combinations of the radioactive elements. Also, it depends on the temperature. More the temperature, decaying of that radioactive element might start quicker. The next point is rate of decay. Now, what is rate of decay? The rate of decay in a simple language can be said as the speed at which a particular radioactive element starts to disintegrate. Because decaying means also means disintegration. Now let us move on to definition. Dn is number of nuclei that decays within the time, where n is number of nuclei which will be decaying or which will be disintegrating within the time interval. Okay, and the time interval is denoted by dp. The formula for rate of decay is minus dn by dt. Why there is the negative sign? Why there is the negative sign? The negative sign indicates the decreasing nuclei because there is a disintegration in the nucleus of the radioactive elements. Hence, it is shown by the negative sign of the minus. It is expressed in dp as it is disintegration per second. Now, this disintegration is calculated in the seconds. The rate law, which is the most important point for your 11th syllabus. Rate of decay of any radioactive element at any instant is proportional to number of nuclei. Is directly proportional to what? Number of its nuclei. So the equation becomes minus dn by dt is directly proportional to n, where it is again denoted by lambda. Now, lambda is the decay constant. Lambda is what the decay constant. So the value for lambda becomes minus dn by dt into 1 by dt where n is equal to 1 by dt, where n is equal to what? 1 by dt. N is number of nuclei, dn by dt is rate of decay at a particular. So the next point is expression for decay constant. Now earlier we have seen this equation, that is dn by n which is equal to negative time. Now if we integrate this equation, we'll be getting integration on both the sides, where ln n is equal to minus lambda t plus c. C is the integration constant. At time t, nuclei is n. At time t0, n is equal to n0. ln n0 is equal to c. Ln n0 is equal to c because here it completely becomes 0. So ln n0 is equal to c. And ln n, that is logarithmic value of n, is equal to minus lambda d plus ln 0. Now we have this value plus c. Now if we put on this lambda, now let's just equate this. Equate the value. We get the value for lambda. Lambda is equal to 1 by t ln n0 by n. Now applying log to the base 10. 10. Lambda is equal to 2.303 by t log to the base 10 n0 by n. Therefore, n by n0 is equal to minus lambda t. N by n0 is equal to minus lambda t. And we get this decay constant. N is equal to n0 e minus lambda e raised to minus lambda t. That is your decay constant. Okay. Now, the next point is related to this equation or related to this equation mainly. Related to this equation for lambda. Okay. Which is known as half-life. We know this equation is for a particular time. We know this equation is for a particular time. But what happens if the time is directly reduced to half? If the time is directly reduced to half. So at t is equal to 0, n is equal to n0. Therefore t is equal to t half and n is equal to n0 by 2, because already we have shown that n is equal to n0. N is equal to n0. Now lambda is equal to 2.30 t half log to the base 10 n0 by n0 by 2. Now this value for 2 goes up here. N0 and n0 gets cancelled. 2.303 t half is log to the base 10 2. We have the value for log to the base 10, that is 0.3010. Lambda is equal to 2.303 t half. If we multiply this, we have 0.693. So value for t half is 0.693 by lambda. The unit of radioactivity, as we know, now see, this is the rate constant. This is the value for rate of decay. dps is the unit for rate of decay, which is expressed in dps as in disintegration per second. Okay. Now, unit for radioactivity is curie. It is curie. Now we have one more unit, that is becquerel, which is equal to 1 dps. 1 becquerel is equal to 1 dps, which makes 1 curie is equal to 3.7 into 10 is to 10 dps, which can also be termed as 3.7 into 10 is to 10 becquerel. Now, as we have discussed earlier, that there are three types of emissions which are generally done in radioactive elements, or which generally happens in a radioactive element. First is alpha decay, beta decay, and gamma decay. Now let us discuss first alpha decay. Alpha decay is emission of alpha particles. They have a charge of +2 and the mass is 4 units. It easily resembles the helium. Hence, it is written as or designated as He24. Now, what happens in alpha decay process? Parent eliminates an alpha particle and produces Y nucleus. This is the general reaction for, you can say, alpha decay process. The next process is beta decay. What is beta decay? It is the emission of negatively charged stream. As we know, हमने पहले भी देखा, we have seen it earlier. Alpha is for plus, beta is for minus, negative, and gamma is neutral. It is what? Neutral. It does not have any charge on it. Emission of negatively charged stream of beta particle. In beta decay, mass is negligible. Mass is what? Negligible compared to nuclei. So during beta decay, a nucleus is formed by same mass, but the original atomic number is increased by a unit, means +1. Understood? Now the last one is gamma decay, which is neutral. There is no change in any of the reactions. There is no general reaction for that. It occurs almost with alpha and beta decay. The main use or the main process for gamma decay is that the daughter nucleus is left energetically excited to the ground state. Now, for the next video, we will be seeing the last part which is to be covered for the chapter, and we will end this. Thank you.